Hello again, higher algebra students. Back here with lesson 4 of unit 7. This is finding information algebraically. Start with just a quick warm up here on what we had from our last lesson. It'll be helpful to keep in mind as we start our new one here. So, just really quickly looking at this, we've got a quadratic here graphed. You can see there's on a scale here we have the point 3, 9 as our vertex, so we'll just dump that over here as 3, 9 as our vertex. Our point of change or pattern of change as we go over 1, we go down 1. As we go over 1 more, we're going down 3 as we go over 1 more. 1, 2, 3, 4, 5. So our pattern of change here is -1, -3, -5. So that tells us what our A value is going to be. Typically, again, our pattern of change is 1, 3, 5. So what A would make it a -1, -3, -5? Well, that would be an A of -1. So just a heads up on that. Our X-intercepts occur both at the origin and then over here again at 6, 0. So those would be our X-intercepts. If we were to write this then in vertex form, again, vertex form is again based off of our vertex. And so when we write this in vertex form, we've got that -1 up front because that's our A here. And then our vertex was at 3, 9, so that would be x minus 3 squared, and then plus 9. And again, that's because it's an x minus h plus k. And so since the h or the x value of the vertex is positive, that just stays as a minus. So x minus 3 squared plus 9, and then again the -1 is out front because it is in with an A of -1. This is going opening down, meaning it's the frown rather than the smile. In terms of our factored form, again, factored form is going to be based off the X-intercepts. So we still get that -1 out front, and our X-intercepts would be an x minus a 0. So that would be, again, based off of the 0, 0 X-intercept. And then we have an x minus a 6, which is based off of the 6, 0 X-intercept. So that would be our factored form. And then again, to go to standard form here, let's take this factored form, -1 and x minus 0 and x minus 6. Again, we have to distribute that A in there. So that actually gives us a -x plus 0. Is technically what that factors out to be, or excuse me, what that distributes out to be. And then an x minus 6, and then we're going to FOIL. So -x times x is a -x squared. Outside is -x times a -6 is a positive 6x, since it's a negative times a negative. 0 times x would just be plus 0x, which of course doesn't add anything. And then a 0 times a -6, well, that's another 0. You could say minus 0, even though, again, it doesn't factor in at all. So that ends up being, here we just have the -x squared, and then just 6x. So it's -x squared plus 6x. Again, I'll write this kind of backward, but that equals f of x here. And so again, the y-intercept here, based on the standard form, is going to be at 0, since it's plus 0. And you can see there's the y-intercept right there at the same spot as the x-intercept. So that's not surprising. But that would then be our standard form right there. So again, that's just a little recap of where we were. For this lesson, we're going to start looking at finding information algebraically, particularly the axis of symmetry and the vertex. And so we'll just jump right into that. So if we look at a problem like this here, where we have, again, standard form in general, and we are supposed to find the vertex here. So what we're used to doing is finding the vertex from vertex form to begin with. In this case, it's a little different. We would have to either move back to vertex form, or we have this little shortcut right here, this -b divided by 2a, that allows us to find the x value of the vertex without having to pull it back to vertex form, because as we've seen, it's pretty nice to move things from vertex to standard form. or at least a little nicer to move it from vertex to standard form than it is to go back the other direction. That takes a little more work. So what actually ends up happening is if you look at the general format of the standard form, and then you look at this little formula here, this means the x value of the vertex is a negative b. Well, in this case, b is actually -6. So this is a -6 over 2 times a. Well, a in this problem would just be 1. So 2 times 1. Well, a -6 is a +6. 2 times 1 is 2. So this means the x value of the vertex in this particular problem would be 3. Okay, in other words, we do know, since the a is a +1 here, that this is something that's, actually I won't even draw it on axes to not confuse, but it's something that opens up. And what we know is that the x value here is 3. Don't know what the y value is yet, but we'll figure that out eventually. But the x value there is 3. And how we find the y value is then a matter of putting this x back into the equation to figure out what y would be. And so to do that, what we would have here is we'd take our y equals, again, now instead of x squared, we're going to write it as 3 squared. So again, I'm just writing this equation with 3 in for x. So that would be that minus 6 times 3, and then finally plus 5 at the end. So 3 squared is 9, 9 minus 18, or 6 times 3, and then plus 5. Well, 9 minus 18 is -9. -9 plus 5 is a -4. So our vertex here would be the point 3, -4. And again, I found the x by using this shortcut here. And then I solved for the y by putting that x of 3 into the equation there. So that's our vertex. Our axis of symmetry would then just be x equals 3, since it's always that whatever the x value is at our vertex, that's x equals 3. This vertex is at the point 3, -4. So that means we know that the overall axis here is something like this, where we're over 3 and down 4 to get to that vertex. This does open up, and again, it opens up because the a in this problem is actually 1, since it was just an x squared, which means since the a is 1, the pattern of change has to be a 1, 3, 5 pattern of change. The y-intercept, if you look at this equation, again, you can find the y-intercept quickly from the standard form. The y-intercept is just whatever's added on at the end. And again, we always write the y-intercept as a coordinate where the x is 0. Now the x-intercepts, we have to find that from graphing. So we aren't going to jump into that right now. It's a little more work, so we'd have to either factor this back out into the factored form, which we'll do eventually, but for right now, we could just throw this equation into a graph and find that x-intercept. But we'll just hold off on that for now. And then does this function have a maximum or a minimum? Well, since the a was 1, it does open up. And since it opens up, that means this would have a minimum. And that minimum is at a y value of -4. So it occurs at 3, -4. So the y value of the minimum would be -4. So again, that's using standard form. The big new thing here was using this shortcut to solve for the x value of the vertex. And then again, just kind of following through our pattern of certain characteristics of these quadratics that are important for us as we move forward. So just another quick example of that same sort of problem here. I'll just do this a little quicker this time. So for instance, again, here we have our standard form. To find the vertex, it would be x equals, again, the negative is already built in, so it's actually a -4, since that's our b, over 2a, so that would be 2 times a -2, since a there is the -2, that leading value. So that would equal 4. 2 times -2 is -4, so that means the x value of our vertex is -1. And again, to find the y value of our vertex, then we're going to take and put this y equals, put that -1 in for x, and solve for that y. So -1 squared right here, -1 squared is 1, so that's actually -2 times 1, or -2. -4, since it's -4, times a -1 is a +4, so that's +4. And then finally the +1 at the end. So -2 plus 4 is 2, plus 1 is 3. So that would mean that our vertex here then is the point -1, 3. And again, because that x is a -1, that means our axis of symmetry is x equals a -1 there. This would open down. And again, opening up or down, if it's up, that's because a is greater than 0. Down is because a is less than 0. And here a was -2. So that would be opening down. The pattern of change, again, by default, the pattern of change that we're used to is 1, 3, 5. But the pattern of change is a result of what that a value is then. And since that a value is a -2, that means our new pattern of change is really 1 times -2, or -2, 3 times -2, or -6, and 5 times -2, or -10. So that, again, is a result of that leading a term to get that new pattern of change. Our y-intercept, again, the beauty of this formula is it does give you the y-intercept. So our y-intercept there would be at the point 0, 1. And does it have a min or a max? Well, we noted that it opens down because of that -2 as the leading term there. So it does have a maximum value, and that maximum value is at the vertex, which is -1, 3. So our maximum y value there is a 3 at the x value of -1. All right. Now, looking at this from another perspective here, in this case, vertex form. Again, vertex form, where this is going to be helpful for us, is it does give us the vertex right out of the gate, just as is. And so we don't need to worry about using that -b over 2a here, because that was really designed for forms that didn't already give us the vertex. So the vertex here, again, that minus is already built into the formula, so that's a +2. And then the k, or this part here, is actually as is, so that's a -5. So our vertex is the point 2, -5 there, which means our axis of symmetry is at x equals 2. Our leading term here is a 1 out in front, so the a is 1, because, again, it just is x minus 2. And so that value would have to just be a 1 in order to keep it as x minus 2 squared there. So this does open up. The pattern of change would stay the same then at the 1, 3, 5 that we're used to. In terms of a y-intercept, we do need to convert this to standard form to get the y-intercept. So if I do that over here, this is really x minus 2 times x minus 2, and then a -5. Again, x minus 2 squared is just x minus 2 times x minus 2. So if I FOIL there, that gives me an x squared. Outside is x times a -2, so that's -2x. Inside is a -2 times x, so that's also -2x. And then outside is last is -2 times -2, so that's a +4. And then we still add that -5 at the end. So this standard formula is going to be an x squared minus 4x minus 1, because again, combining like terms in both those cases. So our y-intercept is at -1, because again, that last term of the standard form will be our y-intercept here. Now the x-intercepts we're not going to focus on yet, because again, that's where where our factored form is more helpful, and we won't jump into that yet here. So just again, finding the vertex, this is a +1, so that means it started out, this was actually x minus -1, so h was a -1 in this case. The y vertex is at 7, so the axis of symmetry is right at what the x value of the vertex is. This does open down because of that -2. Again, if that leading term is negative, then that's going to cause it to open down. Our pattern of change here, again, is going to be that 1, 3, 5, but now times a -2 again. So our pattern of change is really -2, -6, -10, based off, again, the fact that a term is a -2. The y-intercept, again, we're just going to take our x plus 1 and x plus 1, and then we still have the plus 7 at the end. But we do have that -2 up front, so this does make it a little more work because we're going to distribute in that -2 first. So that gives us -2x minus 2 in that first parenthesis. X plus 1 is still the second parenthesis, and then we add 7. Now we'll FOIL. First, -2x times x is a -2x squared. Outside, -2x times 1 is just -2x. Inside, -2 times x is a -2x. And then last, -2 times 1 is a -2. And then we'll add the 7. So that gives us a -2x squared minus 4x plus 5. So our y-intercept here is going to be at 5, again, because of that last term. So that's just a second example. Again, we won't focus on the x-intercept at this point, but a second example of that vertex form. Now jumping over to factored form. So one thing that will make it a little easier right out of the gate with the factored form is to go ahead and get this converted into standard form for some of our other answers. Factored form, again, is really good for the x-intercepts, but it's a little trickier to find some of these other values. So to convert this over to standard form, again, you can see we have this negative up front. So that means our a here is actually a -1. We could put a 1 right in there if we wanted to. But so when we convert this, like we did before, the first thing we're going to do is we are going to distribute that -1 into that first set of parentheses. So that's -1 times x is a -x. -1 times -2 would make that a +2. The x minus 4 will stick along for the ride, and then we can FOIL. -x times x is a -x squared. -x times -4 on the outside would be a positive 4x. 2 times x on the inside would be another 2x. And then 2 times a -4 on the outside would be a -8. So what that leads us to here for our standard form is f of x or y equals -x squared plus 6x minus 8. So finding the vertex here, b in this case is 6, so this would be -6, and a in this case is a -1, so that's really 2 times -1. So we've got -6 over -2, which gives us an x value of 3. So our axis of symmetry is x equals 3, since it's always the x value of the vertex. But let's go ahead and put 3 into our equation so that we can get the y value of the vertex. So I'm going to put in -3 squared here, plus 6 times 3. When you combine those like terms, should be using this right here. So 6 times 3, and then minus 8. And what that would give us here then is -3 squared would be a -9, since 3 squared is 9, and it's a negative version of that, plus 18 minus 8. So that would give us a 9 minus 8, or 1. So the vertex is at the point 3, 1. Again, this is that point where that is going to be either the ultimate max or the ultimate min, depending on where it opens up. And in this case, since a is -1, since a is a negative, so therefore a is less than 0, so that means this would open down, since that's an a value that is negative. The pattern of change here, again, the pattern of change normally being 1, 3, 5. In this case, we have to multiply that by -1, since that's our a term. So our new pattern of change is actually -1, -3, -5. Because it opens down, it's going to be going down as we move over the x's. So that's out. Our y-intercept again here would be the point 0, -8, again, because that's the last term of the standard form. The X-intercepts here, this is where that original formula becomes handy. Because again, what we need is what makes x minus 2 equals 0? Well, that would be 2 minus 2. And so we would need the point 2, 0 to be one of our x-intercepts. And then the other x-intercept would be the point 4, 0. Again, it's whatever makes x minus 2 equals 0 and whatever makes x minus 4 equals 0 from our original formula. That's why the x-intercepts would be 2 and 4. You can see there is a note here about the shortcut to define the vertex is the midpoint of the x-intercepts. So you can see if the x-intercepts were 2 and 4, then the midpoint of those is really just the average of those. So the x value of the vertex is really just going to be 3 there, which of course we found using the negative b over 2a. So this is using factored form to find all of our individual characteristics again, and this one of course is most helpful for that x-intercept. Really quickly, just another example. Standard form here, x squared outside is minus 1x, inside is plus 5x. That's there. And then 5 times negative 1 is minus 5. So this is x squared plus 4x minus 5. So the vertex would be a negative b, which is here is a negative, the b is 4, so that's negative 4 over 2 times a, and a would be 1, since that term is 1 there. So the vertex here would be negative 4 over 2, which is negative 2. And again, if I put negative 2 into this equation, that would be negative 2 squared plus 4 times negative 2 minus 5. Negative 2 squared is 4. Plus 4 times negative 2 is a negative 8, so that's actually plus a negative 8 or minus 8, and then minus 5. So that 4 plus a negative 8 is negative 4. Negative 4 minus 5 is negative 9. So our vertex here is actually the point negative 2, negative 9. Our axis of symmetry then would just be x equals negative 2, since it's the same as the x-axis of the x value of the vertex. Sorry about that. Our opening up or down, a in this case is just 1. There would just be a 1 out front since there is no negative term or any other number there. So this does open up. Our pattern of change then is the 1, 3, 5. It just stays there. Our y-intercept is going to be the point 0, negative 5 because of the last term of the standard formula. The x-intercepts, again, what makes x plus 5 equals 0 and what makes x minus 1 equals 0 from our original formulas. So our x-intercepts would be negative 5, 0 and 1, 0. So just kind of a quick recap of from each form how you find a couple of these different characteristics of these parabolas, these quadratics. So for instance, finding the axis of symmetry. Again, finding the axis of symmetry really starts with finding the vertex. So from vertex form, that's really the nicest. So to find the vertex from here, we've got the minus 7 means that that's a positive 7 since the minus is built into the formula. So the vertex of this one is 7, 1, which means the axis of symmetry is x equals 7. For the standard form, it's that negative b over 2a again. So for negative b over 2a here, that would be a negative 4, since this is b, over 2 times 2, since that's a, and that would be negative 4 over 4, or negative 1. Again, we could use that to find the y value of the vertex, but to find the axis of symmetry, that just means our axis of symmetry is x equals negative 1, since it's just the x value of our vertex. And finally, the factored form. Here, what's the easiest route is really to go ahead and change this to standard form right out of the gate. So we're going to go ahead and distribute that negative 3. So that's negative 3x minus 9, and then x minus 5. And then FOIL, that gives us a negative 3x squared. Outside, negative 3x times a negative 5 gives us a positive 15x. Inside, negative 9x times x. Negative 9 times x is a negative 9x. And finally, last, negative 9 times negative 5 is plus 45. But again, what we're really trying to get to is b over negative b over 2a. And so here, I'll switch colors to shake this up a little bit. So we've got negative 3x squared plus 6x plus 45, which means the negative b over 2a here would be a negative 6 over 2 times a negative 3, which is negative 6 over negative 6. Negative 6 divided by negative 6 is going to give us 1 then. So our axis of symmetry on this one would be x equals 1. So again, that's just finding axis of symmetry based on each of the 3 types of formulas. Vertex is really nice. From standard or factored, you will want to end up in standard form to use the negative b over 2. So here are some more examples for you to work on if you wanted to for axis of symmetry. I will not go through all 6 on this video. But again, if you look at these and questions come from any of these, I would certainly recommend following up and asking about these. Finding the vertex from each form. So vertex, again, very similar to the axis of symmetry, but what we're going to have that's a little differently here is that we just have to finish finding that y value for each. So the vertex form, again, is built to just get the vertex very quickly. We have the x minus h squared plus k. And so that h there was just a 7, as you can see. So that's actually a positive 7, and then the k was a 1. So you can see that that was a positive 1. To find the actual vertex for the remaining 2, you would want to start as we did on the axis of symmetry slide by finding the x first. And if you recall, the x that we found for the standard form was -1, and the x that we found for the factored form is 1. So I'll save you going through that process again. But again, that was the negative b over 2a process for the standard form. And again, we converted this to the standard form here by foiling, and then use negative b over 2a to get that x equals 1 there. So what we would do then to get to the y value of the vertex is just put that x into the equation. So it would be 2 times a negative 1 squared plus 4 times a negative 1 minus 9. Negative 1 squared is 1, so that's 2 times 1 or 2. This would be minus 4 because of 4 times negative 1, and then minus 9. So this would have a vertex of negative 1, negative 11. After you take 2 minus 4 is negative 2, minus 9 is negative 11. Again here, when we FOILed, we got to a negative 3x squared plus 15x minus 9x plus 45. So that was the result of our foiling. So we had negative 3x squared plus 6x plus 45. And so again, we'd put the 1 into that equation to get the y value here of the vertex. And 1 squared is 1 times negative 3 is a negative 3. 6 times 1 is 6, so we add 6, and then we add 45. So that would give us a total here of 48. So the vertex for this would be at the point 148. And again, I have some examples here that I won't go through on this video, but would recommend certainly looking at and letting me know if you have any questions. The last thing here is just really to look at increasing and decreasing intervals. So with this, what you really want to do is you want to identify your vertex first, and then decide if it's a min or a max based on the a. Again, a greater than 0 means it opens up, which means it's a min. If a is less than 0, it opens down, which means it's a max based off of the graph looking like this or like this. So if we identify our vertex first, and this here is in vertex form, so our vertex here is at the point negative 2, 1. Again, that's x minus a negative 2 there in the formula. There is a negative a term, so this would open down. So what we'd be looking at here is, this is the point negative 2, 1. We could put coordinates on here as well if we wanted to. The coordinates would look something like, let's see if this is negative, but the y is positive. something like that. But what we do know is in terms of, since this opens down, that means it's increasing on its way into -2. Okay, so here you can see that it's increasing through here. So it's really increasing from negative infinity to an x value of -2. So this would be increasing. And again, the -2 is not included because that's just kind of the peak of the roller coaster. We aren't going up or down at that point. We're just resting at the top of the coaster before we go back down now. So from -2 to infinity, we will be decreasing. And that then would be, as we look at this, that would be this space here as we continue, make that the green arrows, as we continue to go down there. Looking at the second one, here we would need to find that vertex first again. And because this is in standard form, we're going to use that -b over 2a, which here b is a -4. So this would be a -4 over 2 times an a here would just be 1. So that's a +4 in the end, divided by 2, which means the x value is 2. And so if my x value is 2, now I can go ahead and put that back into my equation to find the y value. We don't really actually need to know the y value since it's really about what the x term is while it's increasing or decreasing. But we'll go ahead and just find it so we can draw up the picture here. So we've got, since the x is 2, I'm just putting 2 in all the x areas here from the original equation. And that gives us 2 squared, which is 4, minus 4 times 2, or -8 there, so -8, and plus 7. 4 minus 8 is -4, -4 plus 7 is 3. So the vertex occurs at the point 2, 3. And again, the a here equals 1, which of course is greater than 0. So this is going to open up, since it's now this here, the top one. So we're looking at a minimum here versus a maximum. And that occurs at the point 2, 3. So in this case, our axes run somewhere around like here and right at the very bottom there for the point 2, 3. And again, we can see this is going to be decreasing into the valley of this roller coaster. And so it's really decreasing from negative infinity until our x is 2. And again, at x equals 2, it's actually not increasing or decreasing, so that is a parenthesis again. And then it's increasing on our way out of that valley. So that would be increasing coming out. And so the increasing starts at the point 2 and really goes on forever to infinity. As always, thank you for listening and watching, and please ask questions if you have any.